Okay, this is the last video for the Unit 1 review. We are going to be finding the inverse again for 21 and 22. So the first thing we're going to do is we're going to rewrite as y equals 2/3 x minus 1. Our first step is to switch the x and the y. So x equals 2/3 y minus 1. I'm going to add 1 to both sides because now we're going to solve for y. That gives me x plus 1 equals 2/3 y. I'll write that up here so we've got some room. Now to get rid of this fraction, we're going to multiply times the reciprocal. So I'm going to multiply times 3/2 on both sides. Remember, when you're multiplying on both sides, you've got to multiply the 3/2 times the x plus 1. So I'm just going to write it on the outside right now of the parentheses. Notice that these cancel out and then the 3's cancel out. Okay, so now I have 3/2 x plus 1 equals y, but we're not done because we want to simplify that, so we're going to distribute this. So then we have 3/2 x plus 3/2 equals y. Okay, so the next thing, in 21 and 22, they also want us to graph that. So let's start with our original equation. F of x equals 2/3 x minus 1, and everybody should know how to graph a line. But we'll go ahead and walk you through that. So, okay, I'm going to do this on a clean graph here. So I have f of x equals 2/3 x minus 1. We're going to graph this one first. So I'm going to start here at -1, okay, because I know my b is -1, and then my m is 2/3, and then I'm going to go up to 1, 2/3, 1, 2, 3, okay, and then I'm going to draw a line. Okay, I don't have a ruler, but I use the edge of this piece of paper to create a line here. Okay, and then I'm going to do the same thing, but now with our inverse function. So it's at 3/2, which is about, or is exactly 1.5. This time I'm going to go up 3, 1, 2, 3, and over 2, 1, 2. I'm going to do the same thing here, and then draw that line in. Okay, I went ahead and sketched in the line y equals x, because we know that they are inverse functions if they are a reflection over the line y equals x. So I went ahead and sketched that in so you can see that these two lines are reflections of each other. All right, let's take a look at the next one. Same procedure. I'm going to rewrite and then switch out my x and y, and then solve for y. So I'm going a little faster because we've done quite a few of these. I'm going to divide 4 on both sides. Okay, so I'm going to rewrite up here 1/4 x minus 2/4 reduces to 1/2 equals y. So there's our inverse function. And then we have our original. Okay, and then we're going to graph each of these. So the first one is 4x plus 2. We know 2, positive 2 is our y-intercept. And we're going to go up 4, 1, 2, 3, 4, and over 1. Okay, and then we're going to sketch that line in using those 2 points. Okay, now we're going to do the same thing for our inverse function. Our b is at -1/2, so our b equals -1/2, so that's going to be where we're going to start, negative. And then we are going to go up 1/4, up 1/4. Okay, and now we're going to graph that line. Okay, and again I went ahead and drew in that reflection line y equals x so that we can be sure that we have a reflection, which means that these two functions are inverses of each other. All right, let's move on to number 23. It says give the domain and range of the function. Use interval notation. Okay, so domain, we're going to start to the left, and we see that my very first x value is going to be -4. Notice that there is an open circle, so I'm going to use a parenthesis because I know it does not include -4. I'm going to keep going, and I see my last value here for x, because we're talking about the domain, is 1. And because this is a closed circle, I'm going to use a bracket. All right, let's do range. We're going to start down at -infinity for the range. And we're going to move up, and we see that our first value here is 1. But notice that there is a gap here. There are no y values in the space between 1 and 2. There are no y values here, nor there are any y values here between 1 and 2. This is a step function. So the only y values I have are 1, and then I jump up to 2, and then I jump up to 3. And we're just going to list it as y equals. And that's it. There are no other y values. There's no y values up here, and there's none down here. So any of this pink space I've highlighted, there are no y values, which means the only y values that exist are here at 1, 2, and 3. And we can simply just write y equals 1, comma 2, put another comma in there, comma 3. All right, let's take a look. Next one. It says circle all the graphs that could represent f of x and its inverse. For each graph, why do you or did you not circle it? All right, so I know that with a graph, what I need to recognize is the reflection over y equals x. So a reflection over y equals x. They haven't given me any equations, only the graph, so that's the only thing that I know, which means that for each of these graphs, the first thing I'm going to do is I'm going to sketch in that line y equals x. Okay, so I'm going to do the first one with you, and then I'm going to pause the video so you can draw the rest of them in. Okay, so that I'm going to, before I even make any decisions, I'm going to draw on those lines. So I know y equals x. I'm going through the origin, 1 up, 1 over, 1 up, 1 over. Sketching in my y equals x graph first. Okay. Now I'm going to keep going and do that to all of those. So if you want to pause the video real quick and go ahead and sketch those in, and then we'll have a conversation about which ones are inverses. Okay, so you should remember lines of reflection from geometry. And the way we described it in geometry is that line of reflection is a fold line. If I fold over the line of reflection y equals x, that blue, and on your case I know it's not blue, but this smiley face should overlap the smiley face on the other side, almost like they were kissing. And before I even fold, I see that that blue is not overlapping that red. So there's no way that these are reflecting over the y equals x line. Therefore, they are not inverses of each other. So 24 is not. I'm sorry, the whole question is 24. This graph is not. All right, let's take a look at the next one. So again, I'm folding over, and these graphs should meet. And you should be able to do this with your paper. I know you can't see it on the camera, but if you do this on your paper, you see that the blue and the red are going to overlap and meet. So it's reflecting over that line y equals x. So this one is an answer. Now you're going to keep doing that. This one, if I fold it over, and eventually you won't have to fold it over. You'll notice, okay, that the blue, if it reflects over the line y equals x, is going to map onto the red. Same thing over here. When I fold that line, the red is going to map onto the blue. So this one also works. Okay, this one here. Notice that if I was to fold this line, this graph here, if I fold it over, is not going to meet the blue graph on the other side. So that one's not one. Taking a look at this one, if you fold it over, you will see they match up. So this is one. Here we can see that they definitely are not going to meet up. The reflection line is a line of symmetry as well. So if you remember that from geometry, this should be symmetrical on both sides of the line y equals x. So that one doesn't work. Keep going, looking at that one, it doesn't, and then finally this one does. Okay, so there are 4 answers to those. Those ones that I circled are ones that work. And again, your reason for all of them would be that the ones you did not circle is because they are not reflections over the y equals x line. Okay, let's move on to our last page. Okay, this question says choose one of the function families that we have studied. Draw a graph of the parent function. On the same set of coordinate axes, draw the indicated transformation. So your answers may vary from mine, but I'm just going to give you a couple examples. Okay, I'm going to start with the absolute value function family. Okay, the parent function would be f of x equals the absolute value of x. Okay, so the first thing I'm going to do is I'm going to draw in my parent function. You know my parent function is going to go through 0, 0. Okay, I went ahead and sketched my parent function in. You should know how to do that. If you need a method, if you don't remember how to sketch the parent function or what it looks like, a good way to do that is to look back on your calculator, because you can actually graph that to make sure that you're doing it correctly. If you go into y equals, I'm going to clear that out, and then the absolute value function is under math, and then over to num. Oh, you can't see that very well, can you? There we go. All right, and then ABS is absolute value. Notice that it puts our absolute value lines there. And we're going to put x in there, and arrow out. So then we have our parent function and graph. Okay, so we know that's what our graph looks like. Now, if you want some points to plot so that you can make sure that your graph is accurate, you can go to second table, and that lists points for you to plot before you actually sketch in the graph. Okay, so let's now take a look at what happens to the graph. We have a transformation of minus 2 on the inside of the parentheses, which means that we're moving what? To the right 2. And then the plus 1 on the outside is going to be up 1. So I always like to write down what's going on before I actually do the sketch. So we know that our vertex is moving to the right 2, 1, 2, and up 1. Okay, and then we can sketch in our graph again, and then we've sketched our parent function and our transformed graph. All right, notice I went ahead and sketched that in. Now, if you want to double check that, you can do that, but you got to go back to y equals, and you have to tell the graph what the transformation is. So I already have my absolute value of x, but I'm going to enter in here the rest of the transformation so I can see if I've actually done the transformation correctly. So minus 2 on the inside, arrow out, because now I need to go on the outside, the absolute value. So plus 1, and now we're going to graph. And it looks like we've done it correctly. So make sure you know what these things mean, but it's a good idea to check it on your calculator to make sure that you have it correct. Okay, let's go on. The next one I'm going to do is the quadratic function family. Remember, you can choose whatever you want. I'm just doing these 3 as an example. If you're not sure, because I didn't cover it in the video, please ask your teacher directly and they can let you know whether you've done it correctly or not. So quadratic. Okay, my parent function of a quadratic is parent function equation is f of x equals x squared. All right, I'm going to go ahead and put that into my calculator because I want to see that graph. Just to make sure I'm doing it right. So we know f of x, which is y, equals x squared. going to graph. Okay, we have our nice parabola. I want to make sure that my graph that I'm actually sketching looks nice. So I know that it starts at 0, 0. I'm going to go ahead and plot a couple more of these points. So I go at 1, 1, 2, 4, 3, 9 is off the graph, and then going the other way, I go negative 1, 1, negative 2, 4. Okay, so then you can sketch it. Remember, this is a U shape, so be careful when you're actually sketching the graph. You want to make sure that it looks like a U. I'm sure Miss Applebacher can sketch this way better than I can, but this is a U. Okay, and then if you hit the graph, it looks similar to that. All right, and then we're going to look at our transformation here. So I'm going to talk through what the transformation is first. Okay, so let's take a look to see what happened, what transformation that we made. Because I chose a quadratic, the negative x inside the parentheses is not going to have an effect on the graph. Now that could change depending on what type of parent function you're using. And then I know that minus 2 means down 2. Okay, so I know that vertex is moving down 2, so here's my new vertex. Okay. Now, what I'd like you to do is to get a graphing calculator and take a look at that. So that's going to be x squared, and I'm going to compare that to my function negative x squared minus 2. Now the reason why I wanted you to look at this way, because you notice that that's squared. Okay, if we square a negative number, it's going to be positive. That's why in this particular instance there's no effect on that graph. So we're going to hit graph, and it's first going to graph our parent function and then our transform function. If we go ahead and take a look here, so we have 0, this one right here, the y1 is our parent function and the y2 is our transform function. So then I'm going to go ahead and plot a few more of these points and then sketch in my graph. And there is our sketched in graph. Okay, again, if you have questions about if you didn't do a quadratic, if you did something else, please ask to make sure that you've done it correctly. You can also put it into your calculator to make sure that you have done the graph correctly in the transformation. Okay, let's take a look at the next one. I'm going to use the square root function. Okay, and I know that my parent function equation is f of x equals the square root of x. This is in the radical function family. Okay, so let's go ahead and graph our parent function first. Okay, so I know that I'm starting at the origin again. Now, if you want to graph it, you can either make a table of values, but I'm going to go ahead and use the calculator. So I have the square root of x as my parent equation, and then I'm going to graph so I can see what it looks like. But I can also go to that table of values again, okay, to graph a few points so that my graph is accurate. Now let's take a look here. Okay, so I'm going to just look here. I see that the negative means that there's going to be a reflection over the x-axis. And then that 2 means I'm going to have a vertical stretch. And then the plus 1 on the inside of the parentheses means that I'm moving left 1. Okay, so I'm going to go ahead and start here. And I know that I need to move left 1. Okay. Because I have that reflection, I know that I'm going to reflect over the x-axis, so my graph is going to be going this way. but I also need to address this vertical stretch here. So let's go ahead and take a look at that in the calculator. I'm going to leave my parent function in there for comparison purposes. So I have -2 on the outside times the square root of x plus 1 on the inside, and arrow out. Let's go ahead and graph, take a look. So we see we've moved over 1, and we've got the reflection, and notice that we have that vertical stretch here. So to get the most accurate sketch, we're going to go ahead and look at our table of values. Notice the y1 is the parent function, and then the y2 is the transform function. Notice at 3 we're at -4, so that's an easy point to plot there. So, okay, and then if we keep moving down, we're kind of going off the graph there, so we'll go ahead and just sketch that in by the information we have there. And there's your transform graph. Again, you can use any function family on these. I just gave you 3 examples. If you have questions on whether you did it correctly, check your calculator, but also please verify with the teacher. All right, let's look at our last problem here, number 28. We have number 28 says draw a graph of a function which has the indicated graphical characteristics. So this is kind of making you go backwards a little bit. We're not telling you what the parent function is. We're giving you some characteristics to see if you can actually sketch that graph. So let's start with the end behavior here. So as x goes to infinity, okay. So what I'm going to do is I'm just going to kind of draw what that's going to look like before I sketch it over here. So I know that when as x goes to infinity, my f of x is going to -infinity. So something's happening where as I move this way, I'm going out this way. I don't know what, but it's got to look like this, because as I go to positive infinity for x, I know my f of x is going to -infinity. So let's take a look at the other side. As x goes to -infinity, well, f of x or y is going to -infinity again. So I know that it has to be going somewhere like that, because I know that the x is going to -infinity, and so is y. Okay? All right, so then I have a local maximum of -2, 4. So I know that that's some type of turning point, a local maximum. So I'm going to go ahead and put that in. We've got -2, 4. Okay. And they don't give us any other information. Well, they didn't say how many turning points there was. It says it has a local maximum, but I know that the end behavior, that my graph has to be going down to -infinity for y on both ends. So I would sketch in, with the information they gave me, I would sketch in a parabola. Because I know that it only has one turning point, and that if I have the parabola that's facing down, I know that I meet the conditions of my end behavior as well. Again, if you're not sure, if you've drawn something else and you think that it's correct, please check with your teacher on this one as well. And that is it for Unit 1 review.